Hello friends, welcome to Engineering Funda family. In this video, I am going to explain you how sliding window protocol is implemented in TCP. In my last few videos of computer network lecture series, I have explained you how TCP segment header is there and how TCP functions along with connection establishment, data transfer and connection termination. Right. In this video, I'll explain you how we have sliding window protocol implementation in TCP. See, in TCP, you will be observing hybrid sliding window protocol that is used. Why it is hybrid sliding window protocol? The reason is, in sliding window, we are having two broad categories which are implemented in computer network. One is selective repeat and second is go back N. And features of selective repeat as well as go back N both are used in TCP. That's why you can say in TCP, we have hybrid sliding window protocol. If you observe selective repeat, in that few features that you should know. First is sender window size that is equals to receiver window size. And here in TCP, I have explained you in connection establishment, both of these computers will be establishing connection with three-way handshake. And in three-way handshake, they will be giving information of window size to each other. Like for example, if I say sender is giving information of window size, let us say that is 10,000 byte over here, right, to receiver. So receiver will get to know sender is having 10,000 byte of window size which is available. Then receiver, let us say receiver is saying I am having 15,000 byte of window size and it is getting forwarded to sender. So now sender and receiver both are having idea about what are the available window size which is there with these two computers. And at last they will be agreed upon minimum of these two. So here minimum of 10,000 and 15,000, that is 10,000. So in transmission they will get agreed upon 10,000 byte of window size which will be there at sender and receiver. So here if I say sender window size and here we are having receiver window size, then they will get agreed upon 10,000 byte, right? They will get agreed upon 10,000 byte. And in selective repeat, you should know sender window and receiver window both are equal. So that is implemented here in TCP. Now second interesting feature of selective repeat, that is it accepts out of order segment. Now out of order segment means what? Let me explain you that by one practical example. Let us say here one segment is forwarded by sender to receiver, right? Let us say sequence number of this segment, that is let us say 10,000, right? Sequence number is 1000. And let us say receiver is waiting for sequence number, that is 500, right? So here receiver is waiting for sequence number 500, but sender is sending sequence number 1000. Let us say here size of this segment, let us say that is 500 byte, right? Now if you observe here, receiver is having window size that is 10,000, and obviously receiver is waiting for this sequence number that is 500, right? But see, sender is sending sequence number which is 1000. So 1000 will be somewhere over here, right? 1000 will be somewhere over here, and size of this segment that is 500. So here 1000 to 500 plus minus 1 means 1000 to 1499. See, this many bytes that is forwarded over here. This is out of order, but it will accept it. Why? The reason is this segment that we can store it in this receiver window. So as and when whatever segment that comes over here at receiver, and as if we can store that in receiver window, then this receiver can accept out of order segment. Like if in receiver we can store 5 segments. Let us assume that we can store 5 segments. Right now, receiver is waiting for segment number 1. But if sender is sending segment number 3, then also receiver can store that inside that window. That's why receiver here can receive out of order segment. And that is what I have shown you by one practical example. That is how practically it is happening, right? As per sequence number and size. In terms of numbering directly, I can tell you. But practically you should know, the reason is in competitive examination, questions are coming like this. For example, if window size is this and receiver is waiting for this sequence number, and if segment is forwarded like this, and if segment size is this much, is it possible that receiver can receive that segment over here even if it is out of order? So that is how questions are coming. So you should be ready for this type of tricky things, right? Now let me explain you few more things. You see here, go back and ARQ protocol, that even I have explained you in my lecture series of computer network. You just go through it, definitely will get complete details regarding that. But here I just want to explain you few basic things. Like you see here with go back and we are sending cumulative acknowledgement. Now cumulative acknowledgement means what? See here, as if sender is sending data to receiver. Then as per basic sliding window protocol, what we need to do is we need to give acknowledgement for every received segment. Like as if you talk about sliding window protocol, basic structure. In that what we do is, whatever segment that is forwarded by sender to receiver, for that every time there will be acknowledgement. But with go back and ARQ protocol, you don't need to have acknowledgement for all the received segments. Here you can give cumulative acknowledgement. Means you will be sending less number of acknowledgements over here, right? So in go back and I have explained you, we are having cumulative acknowledgement. Cumulative means for 5 received segment, 1 acknowledgement can be given, right? It is up to receiver. Receiver can decide in which segment I should be giving acknowledgement, right? So here cumulative acknowledgement, that functionality that is there with this TCP sliding window protocol. So in total what you can say is, here hybrid sliding window protocol that is implemented in TCP. So features of selective repeat and go back and both are implemented, right? And see this sender window size and receiver window size, that has been decided during connection establishment, right? So during data transfer, sender and receiver both were been having idea about what are the window size, right? And that has been decided based on lower of those two hosts. Secondly, you should know it accepts out of order segments, and that acceptance is possible only if those segments can get fit inside window. See, it can accept out of order segments, but it is not like if it is not getting fit inside window, then it is not possible to get accept, right? So that even you should know. If it is possible to fill that segment inside window, then only it can accept. And in go back and I have explained you, we are having cumulative acknowledgement. Means for every received segment we don't need to forward acknowledgement. Here cumulative acknowledgement that can be given. That is how sliding window protocol that is implemented in TCP. I hope you have understood this. Still, if anything that you would like to share, please note it down in comment section. I'll be happy to help you. Thank you so much for watching this video.